All right, so we got R6 and R7. I had the second page of notes. I had another quadratic here with complex solutions, and I told you that we would knock it out next. So let's do it. We're going to solve negative 5 halves d plus 1 is equal to negative 3d squared. We discussed, we just kind of talked aloud about this problem and how it is a quadratic. It may not appear to be a quadratic because it's a big old mess, and the really scary part is that fractional coefficient. Nobody likes fractional coefficients. That's not true. I like fractional coefficients, but I am also a fan of many things that my students are not. So let's get everything on one side. It means adding 5 halves d to both sides and subtracting 1 from both sides. Everything on the left is going to go away. Zeros out, zeros out. And then on the right, I'm going to go in descending order of power, 3d squared plus 5 halves d minus 1. And let's make life super easy and clear the fractions. All right, to clear the fractions, I need the LCD. LCD is what? Well, negative 3d squared is a denominator of 1. 5 halves d is a denominator of 2, and negative 1 has a denominator of 1. Least common denominator here is 2, which means I'm going to multiply both sides by 2, which is great. On the left-hand side, 2 times 0 is 0. 2 times negative 3 is negative 6. 5 halves times 2 is 5. And negative 1 times 2 is negative 2. And now I have a quadratic. My coefficients are what? A is negative 6. B is 5. And C is negative 2. And now we're going to plug this into quadratic equation, remembering just that little aspect that quadratic equation says that the solutions of the quadratic are opposite b plus or minus square root b squared minus 4ac all divided by 2a. Whatever variable you're solving for is what goes on the left-hand side. I just have a d because that's what's after it. Typically, you'd see an x there, but let's plug everything in. Opposite of 5 is negative 5, plus or minus the square root. 5 squared is 25. 4 times a is negative 6 times c is negative 2. I haven't seen one of these. All right, and we know we're in the complex portion, so that's kind of what we expect to happen here. I'm just gonna see if it'll let me grab and scoot so I can give myself a little bit more space on the right. So I'm just gonna continue with that form, negative 5 plus or minus the square root of 25. Now this is minus, and let's see, what are we subtracting? 4 times negative 6 is negative 24. Negative 24 times negative 2 is positive 48, so that is 25 minus 48 over negative 12. 25 minus 48. What does that do? 25 minus 48 comes out to negative 20. What? Okay. Well, it'd be almost 25. It would almost be 25, but it's not. So I think it's negative 23 here. Over negative 12. I have a negative under the root. This means my answer is complex because that discriminant is negative. And then I can split it. The 23 does not have any factors that are any perfect square factors. So I can, let's get this going. to the other side. That's negative 5 divided by negative 12 plus or minus, and then square root of 23 divided by negative 12i. And then this splits into, well, let's clean up one more step here. Negative 5 divided by negative 12 is just 5 over 12. So there's the real portion, and then here's the imaginary portion, plus or minus. This is negative square root of 23 over 12, which is going to do something interesting. We haven't run into this before, so let's talk it through. 23 over 12i. What does this do? If I was writing this out, this is a plus minus a negative. Mathematically, what happens here is this becomes a minus plus. It doesn't actually change anything for us, but if you ever have to distribute a negative through a plus minus, that's what happens. So my solution set has 5/12 minus square root of 23 over 12i, 5 over 12 plus the square root of 23 over 12i.